Hello, it's Keith here, and this is the fourth and final of the main series of the MinTile tutorials. This is where we're looking at the common tile map code on the 68000 systems. Now what we're looking at today is the so-called zeroing of the sprite in the cache. Now MinTile doesn't use a double buffer, so the only thing that is being drawn is what you see on the screen, and this means as the things move around the screen, if I move my character sprite around, you'll see that there's flicker, and this is because as our sprite moves around the screen, we need to remove the sprite from the screen by drawing the background in and then draw the sprite back on the screen. But what about if the sprite only moves a little bit, which it will do in most cases? Well, we would draw the background on, but then we would immediately overlap that background with the new sprite. So there was really never any point drawing that background in the first place. And that's what zeroing the sprite in the cache actually does. The cache is the tiles that need to be drawn back to the screen for the next update. And the zeroing is setting those entries in the cache to 0, meaning no update is made if we know that the new sprite is going to overlap the position. And so you can see as the character moves, only the edges flicker because the middle part has been zeroed in the cache. Now that's what we're going to look at in today's tutorial. That's what we're going to look at. So let's go over to the code and let's take a look at how this zeroing actually occurs. Now, one thing I should point out is that this zeroing routine is a bit naive. It only really looks at the object as a square, and if there's complex transparent parts, it might start to cause glitches. Parts of the sprite can have zero tiles, which are effectively transparent tiles, and it can get a bit glitchy with those. I am working on an improved graphics engine called MaxTile, which resolves that. MinTile is only a very simple one, so that is something that's a limitation of this version, but generally it works pretty well. Okay, so let's take a look. Now the first thing zero sprite in cache does is it checks the refresh tile flag to see if the tile map is going to be redrawn, because if it's not, well, there's nothing to do and we simply return. Otherwise, we're going to load in the parameters of our sprite. So we're loading in the X and the Y pos here, and basically what we're doing here is if we've got low res set, we're converting that to a number, to a tile position. We're just rounding that to convert to a tile position, and then what we're doing here is we're getting the width and the height of our sprite here. Now the next thing is only going to happen if we're allowing the objects to move in less than one full tile movements. On the bitmap systems and on systems with harder sprites, we can move by half a tile, but this causes issues because if you're half a tile in, well, you're still overlapping the first tile, but you're now overlapping one extra tile as well. And in that case, we're basically rounding up the X position of the tile and subtracting 1 from the tile width, and this is to make the area we zero smaller so that there's a wider gap around the sprite which is going to be redrawn, because otherwise that would end up showing parts of the original sprite. So that's what we're doing there. We're doing that here for the X position and then here for the Y position. So that is changing the area, because we're not going to zero the entire sprite because that wouldn't do anything. That wouldn't redraw anything. We're only going to not redraw the very center of the sprite in its new position so that we aren't wasting any tile draws. Okay, now what we're doing next is we're loading in the address of the source tile map, and then we're going to do the crop routine, because we need to work out where our sprite is on the screen and where it's being drawn, and then we need to look at the tile data that was contained within it to work out the transparent areas that we do still need to redraw. So that's why we're doing the do crop there. If that results in 0, we're going to return. Otherwise, there's something to draw. We're using do crop logical to tile to convert our X, Y width and height to a number of tiles. And then what we're going to do next is we're going to shift the tile cache, which is our destination cache of the draws that will occur next time. We're basically moving the source address of the tile cache to the X and Y position, because if our sprite is here, we want to start drawing into the tile cache from this corner position here. So that's what this shift to tile map here is doing. Okay, so we've now calculated that, and what we're going to do next is we're going to do our zeroing routine. But the thing we still need to do is we just need to check to see if we are basically X flipped or not. And if we are, then basically we're going to work in reverse here. So we're just calculating for that, and we're setting a flag here to mark that we're going to work in reverse. Now what we're going to do next is we're going to process the sprite. So basically for each of the tiles within our sprite, we're checking to see if the source tile is a 0 tile. Now if it's a 0 tile, then this is basically a transparent area of the sprite. So like in this character, this black area here would be a 0 tile, and so in that case we don't want to blank the cache because we need that to show through to the background tiles. So in that case we would skip, but in the other cases we would clear the tile to a 0, because we've already calculated only the middle area of the sprite. So the only thing left to do is to check if the middle areas of the sprite are actually transparent, and so if they're not, we're clearing that entry in the cache here. We're then increasing our destination here, and what we're doing next is basically going to depend on if we are working in ascending or descending order. If we're working in ascending order, then our increment was done here, but if we're working in descending order, we're actually reversing that and doing a decrement here. What we're then doing is we're repeating for the remaining tiles on each horizontal line, so we're going across the tile and we're going to move down, and then what we're doing is we're moving down the destination tile cache by adding D7 to A2 here. That's the destination tile cache. We're then adding D3 to A3 here, which is the source tile cache, because of course the source tile map, because of course our sprite could be cropped, so we're not necessarily processing all the data on each line. So that's why we are assuming that we aren't, and we are adding the width of the tile map there, and then we're repeating until we've done the entire line. And it's basically that line there that's doing all of the work of zeroing the entries in the sprite unless they're transparent, and that's dramatically reducing the amount of flicker. I mean, it's only a simple thing, but it did work pretty well. As I say, on 16-bit systems, in most cases, there isn't a lot of reason not to use a double buffer. You've got a lot of processing power, and memory tends to be pretty abundant. So generally speaking, you would say that it's not necessarily that useful. But as I said before, even on the Sinclair QL, there is a very good reason you may not want to use a double buffer, and that's because the way the memory map is configured on the hardware, there's only two possible memory addresses you can use for the screen address, and one of those is the default one that's being used here, and the other one is actually used by the parameters for the operating system. So if you use a double buffer, you can't use the operating system because you've just trashed all its variables. Very unusual choice, shall we say. I don't quite know that I agree with that choice, but that's what they did. So if you want to program that system, that's what you have to work with. Anyway, I hope you've enjoyed what you've seen today. Please like and subscribe, as I always say. We're going to carry on with MinTile. We've done all the main multi-platform code, and we're going to go into the platform specifics. So you're going to see reasonably fast tile map drawing routines for each of the systems in my tutorials. So please stick around for that if you want to see how to draw graphics in 8x8 tile blocks to bitmap and tile-based systems in the same way. Anyway, I hope you've enjoyed what you've seen today. Thanks for watching, and goodbye.